For my experiment, the reactants were lead nitrate in aqueous solution, potassium iodide in aqueous solution to get the products of lead iodide in solid form and potassium nitrate in aqueous solution. In my video, I'll be working out the percentage yield of lead iodide from lead nitrate. So using an example from my experiment, I will work out the percentage yield. So in the experiment, using a volume of 0.03 liters of lead nitrate, a mass of 0.15 grams of lead iodine was formed. Note, the density of lead nitrate is 4.53 grams divided by centimeter cubed. So calculate the percentage yield with the knowledge given. To calculation of values, I made a table showing the chemical equation and moles mass, molar mass. So since potassium iodide and potassium nitrate aren't really needed to work out the percentage yield of lead iodide, we can just cross that out and they're just lines. So the information we know so far is that we definitely know the molar mass of lead nitrate and potassium iodide. So let's work that out. So for lead nitrate, the molar mass would be equivalent to the periodic table masses added together, since molar mass and the periodic table mass are relatively the same. So we would get lead 207.20 plus 14.01 times 2, which is the nitrogens in the compound, plus 16 times 6, which is the oxygens. So this would give us a value of, this would equal 331.2. So we can plug that in right here, 331.2. And the molar mass of lead iodide would be lead plus iodine, which was 126.9. But since there is two of them, we multiply it by 2, and this gives us a value of 461.0. So we can plug that in here as well. So now we know the molar mass. Next, we should find the moles. But here we know that the coefficient of lead nitrate is 1, so that's 1. And we know the coefficient of lead iodide is 1, which is also 1. So with this information, we know the amount of moles in lead iodide is the same as the amount of moles in lead nitrate. But now, since we are given the values that the volume is 0.03 and the density is 4.53, we can work out mass. Using the equation mass equals density multiplied by volume, we know that mass equals 4.53 times 0.03. So mass equals 0.1359. But here we see that it is 2 decimal placing, so mass equals 0.14. And we can plug that in, 0.14. So now we have the mass and molar mass of lead nitrate. We can work out the moles, as moles equals mass divided by molar mass. So N equals 0.14 divided by 331.2. So N equals 0.00041. So we can plug that in 0.0001. But since we know that 1 mole, and that they are equivalent to each other, we can also plug in 0.00041. So now we know the moles and molar mass of lead iodine, so we can use the equation N equals M divided by big M to work out the mass. By rearranging this equation, we can get N multiplied by molar mass, well, moles multiplied by molar mass equals mass. So that is 0.00041 times 461.0 equals mass. So mass equals 0.1891. But once again, it's 2 decimal placings, so mass equals 0.19. So now that we know the actual mass was 0.159 and the theoretical mass is 0.19, we can work out the percentage yield. Percentage yield equals actual mass in grams divided by theoretical mass in grams as well, multiplied by 100. So based on the information given, we know that the actual mass is 0.15 and the theoretical mass was 0.19. Multiplied by 100, and we get 78.9%. this is the percentage yield of lead iodine from lead nitrate in this equation. So if we go back up here, calculate the percentage yield, 78.9. And that is it.